Just follow the notes. Correct. Now, why I'm telling it, let it be recorded in case someone wants to see certain part of it, then they can see it. Correct. Now, follow the notes rather than writing down something. Just listen. Just hear me out. Just hear me out. Again, full board is seen, no, Preksha?
Yeah.
Yeah. So the very first part is where from the electric field I am trying to generate magnetic field. That means whenever a current is flowing through a conductor, there will be magnetic field produced around it. So now, let's say whenever you have a battery, this is nothing but direct supply of current. That means you should think about experiments like Oysters experiment, current carrying coil, and the third thing is an electromagnetism, which is basically nothing but solenoid. So these are the three things that you need to remember. Based on these three things only, and if DC is being supplied also with respect to the rules, if I have to see, I have to think about DC motor. Okay. This is where I'll have all my answers related to whenever there's a battery related to it. Whenever battery is there, you see a battery, question should be framed from there. So what does Oysters say? Remember the conclusions. Okay, conclusions are more important than anything else. Conclusion is important, and also the setup. Setup generally they don't ask, but in case, because Ohm's circuit diagram is always being questioned, so this is also necessary. So here what we try to do is we try to connect a compass. Okay. Whenever a compass is resting freely, it always comes to rest in the north-south direction. The arrowhead of the compass always points towards which direction? Okay. So suppose this is the scenario, and let's say the load is there or it is not there, it doesn't matter, P is there. Battery. Okay, I connected over this. Now when the current is not flowing through this, what does the compass indicate? It is resting in north-south direction. So when it is resting in north-south direction, even though they don't give you the scale, when I say scale or the compass, I mean with respect to the geographic compass. When they don't mention it, please, with the compass, please find out your north, south, east, west. So this is north, this is south. So basically this is north, this is south, this is east, and this is west. Now the moment current, let's say the key is connected, what happens? Current is flowing through. And when the current is flowing through, yeah, the compass will show deflection. And whenever the compass shows deflection, what is the rule? Abey Gochu Ram. Right hand thumb rule. Right hand thumb rule. But how will you find it? So use your jugaad to find the necessary result. That is nothing but snow. What does snow rule state? Snow rule states that if current is sound distance, if current is flowing from south to north such that wire is over, then deflection will be towards the west. And always see to that you make 3 columns. Okay. So when I make 3 columns, 1, 2, 3, yeah. So first column is where you have your current, second column is where the wire, third column is the deflection. Okay. Now they will not give us such easy questions and I don't expect all those things. But still I am doing this. So right now the current is going in this direction. That means it's flowing from south to north. As per snow rule, should the current flow from south to north? Answer is yes. So when it is a yes, it is positive. Okay. And wire. Do you see any solid line inside the compass? No. That means the compass is over and the wire is beneath, underneath. So wire is below the compass, which is negative. Positive into negative will give you a negative answer. So as per snow rule, the answer should have been west. But since it is negative, it is east. So east is downwards. Okay. Now also questions related to this. Like for example, you know the deflection is east. Suppose let's say I show one deflection like this, where it is A, another deflection which is B. Let's say this is there. Okay. What can you comment in with respect to case A and case B? Case A is where the magnitude of current is lesser. Case B is where the magnitude of current is more. This is what I can conclude. Correct. More the deflection, more is the magnitude of current. What did I say? More the deflection, more is the magnitude of current. Okay, check on this and rule. Again, but as stated, sir, they will not give you questions based on all this crap. Okay, they will not give you questions based on this. Rather, question will be something like this, where you have to find out, let's say, the same question. I'm just trying to change it. So this is the deflection. Given to you is this, and the geographic compass is given to you: north, south, east, and west. A and B. First and the foremost thing, A and B are battery, and let's say the key is, okay, key is here. AB is a battery. Okay, where you have to find the terminals. What do you have to do? Find the terminals. And key is connected or not. So how will I know key is connected or not? The reason is key is connected because deflection is present. Key is connected. Why is the key connected? Because compass shows deflection. So since the compass is showing deflection, I can state that current is flowing through the circuit, which indicates that circuit is closed. Now to find out whether A is positive or negative, I know this is the compass. Correct? I know which is east and which is west. So I'll just mention over here, this is north, this is south, and deflection is towards east. So again, same scenario, I'll make 3 columns where deflection is given there, wire is this, and this is the current. So what will you do over here? Deflection, when it is given to you as east, as per snow rule it should have been west, so this is negative. Wire is below, which is also negative. So now I have this as negative. In order to see to that I get deflection as negative, that means this has to be positive. Positive into negative should be negative. Now this indicates that if it is positive, as per snow rule, the current has to flow from south to north. That means in this direction. If it is flowing in this direction, it indicates that A is positive, B is negative. Clear? This is how the questions will be. Do not expect like that question, dumb questions. Expect these type of questions. Okay? So this is where one set of things. And what is the rule? Rule is right hand thumb rule. No snow rule. Don't write and come snow rule and all. Guchu. Okay? Please write right hand thumb rule. Okay? What is the conclusion of Oersted? He says that whenever there is a current carrying coil, okay, or a current carrying coil always produces a magnetic field around it, and the magnetic field will be concentric circles. Okay, magnetic field will always be in the form of concentric circles. So I'm erasing this part, it is not required for me. A current carrying coil always produces a magnetic field around it, and the magnetic field are always in the form of concentric circles. A minimum of 3 circles have to be drawn. Okay, a minimum of 3. Will they ask 50-50. 50-50, I will say. Okay? Because there are much more questions where they can test you on. Okay? So here the current is moving up. So again over here you need to know two rules, which is nothing but clockwise and anti-clockwise loop. So suppose a current is being carried in the clockwise direction, which is clockwise, this is clockwise, correct? A south polarity is being produced. But if the current is in the anti-clockwise, north polarity is being produced. And which is this rule? Remember the rule? Clock rule. Remember the rules, guys. Clock rule. This is your clock rule. Clockwise current, south polarity, anti-clockwise current, north polarity. So when the current is going, how do I use my right hand thumb rule? Definition of right hand thumb rule, state, right hand thumb rule and all will not come, don't worry. Some places you can skip, so skip peacefully. Right hand thumb rule says that if I place my thumb in the direction of the current and see to that the other four fingers are curling the wire or the conductor, the direction in whichever direction the four other fingers are curling or moving around the coil is the direction of your magnetic field. Okay, so in this case it is moving in clockwise, anti-clockwise direction, correct? So anti-clockwise magnetic field indicates that it is north polarity is being produced on the face of it, on the face. So it is now in 2D format. So when you see something, it is always a 3D format, right? It is a 3D format. So let's say this is the wire. The current is flowing in this direction. Current is flowing in this direction. So suppose you are seeing underneath. Okay. So you will see nothing but, or let's say this is the scenario. The current is flowing into the plane. So how will you see same scenario? This is how the magnetic field will be. Magnetic field is clockwise or anti-clockwise? In this direction, guys. In this direction. Don't see with respect to me. 12 is here, 6 is here, 3. So it's going in this direction. Clockwise. So this polarity will be
South polarity.
So this side will be
North polarity.
here. It's always a 3D format that you need to check on. So try to understand where it is going. It is going into the plane or it's coming out of the plane. Based on that, you will have to decide the question. Okay. Here I have not mentioned whether it is going into the plane or out of the plane. So that's why I am not able to frame the question. But let's say the current is going into the plane. Which is the plane? This is the plane. I am the plane, right? So it is going into me. So now when you see that, you place your thumb is in this direction, right? And you see that the other four fingers are curling the duster in this direction. So when it is moving in this direction. The magnetic field, right? So magnetic field is clockwise. So clockwise indicates this polarity is south. This polarity automatically will become north. So which is the polarity that you see?
South.
You always see the polarity wherever the current is going, entering into. The other side will be the opposite polarity. Keep that in mind. Okay. Now another thing. This magnetic field line. If I have two magnetic, so let's say magnetic material in two places, one is at point A, another one is at point B. Okay. Where will the magnetic strength be more? On A or B? A. The magnetic field that is more closer to the current carrying coil will show more magnetic strength. Clear? And as and when you go farther away, what happens? The magnetic strength decreases. Questions can be also in this way. If this is magnetic field lines with 3 and another one I have with a magnetic field line of, let's say, 4. Okay? North anti-clockwise direction. Okay? If I say that this is 5 ampere amount of current is flowing through this wire, will this be more than 5? Less than 5? Why? More magnetic field lines are present. Okay? So these type of objectives can pop up. Okay? More magnetic field lines. Clear? Any doubts? All peace? This one you got? Yeah? Over here, again, some people generally face some difficulties with respect to understanding whether the wire is below or the compass is below. So, whichever you see is in dotted lines. Whichever you see that is in your dotted lines is basically nothing but underneath. So suppose I see a wire which is solid and let's say the compass is in the dotted line. What does this mean? Wire is over. Wire is over. If I see to that compass is solid, now this is wire is below. We are always interested in wire which is also your conductor. They can also give it in the form of conductor. Wire is basically your conductor. Compass is not your conductor. Suppose I see a dotted line inside the compass. It means again wire is below or beneath. Yeah. Here, scenario where suppose in case a solid line is seen. Now you see. Now in this case is nothing but wire is over. I did not show the compass in dotted lines, but still it matters that you see a solid line of the wire. Okay. And the last but not the least is this one. If the compass is anywhere inside, something like this, anywhere inside the circuit, it means wire is over. And if I see the compass anywhere outside, okay, anywhere, wire is below. Wire is below. I hope you remember all this. Okay? Clear? Suppose I have current carrying wires in the opposite direction. This question was asked in CFQs. This question was being put across in CFQs. Here it is south polarity, clockwise, clockwise, clockwise. Now if I see, look into this, the magnetic field line in this direction is going upwards, here also upwards, result of which at point K, the net magnetic field will be okay. Suppose let's say this is 10 ampere current. Point K will be towards this or wire 1 or wire 2. Wire 1. It will push away. No? This will have more magnetic field lines. So this will have more magnetic field lines. So the point of maximum magnetic field, K is nothing but point of maximum magnetic strength will be towards wire 1. Okay? Towards wire 1. Because wire 1 has lesser amount of current than in case of wire 2. Okay? Same scenario, let's say now the current is moving in the same direction. This is south polarity, so clockwise. Okay. Now point K is a point where your net magnetic field is 0, neutral point. So this will come like this around, it will bend. It will move around like this, it will bend. Bean shaped, kidney in this current carrying coil. Write and thumb rule, sir. Don't write clock rule and all will come. They will not ask you questions related to clock rule. This much I can suggest you. But if an option is given where it is clock rule and right and thumb rule, माँ कसम आँख बंद करके right and thumb rule मार के आओ.
I don't know when this is. Stop recording.
It is getting recorded anyways.
I know.
Now coming to solenoid. Okay. So solenoid is all with due respect to electromagnets. That means when current is flowing through a conductor or nothing but the wires which is wound around anything. So what will happen? That will start behaving like an electromagnet, where I can reverse the direction of the magnetic field and I can increase the strength of the magnetic field depending on my wish and my will. Okay? Physics apply. So your wish, however you want to. So yes, questions related to ways of increasing magnetic strength. This is there, where you use the magnitude of current, number of turns
By placing a soft.
in the coil and placing a soft iron core. Placing a soft iron core. Yeah. Apart from that, nothing else where you need to know. Now you need to know the directions. Again, in a solenoid, how do I find out the directions? Right hand thumb rule. आँख बंद करके right hand thumb rule मार के आओ. No clock rule, nothing. Questions are not framed on it till now with respect to clock rule. So suppose I state that this is positive and this is negative. What will happen? The current is flowing through. There are only two cases, guys. If the wire is over or wire is below. And always be interested in where the current is entering from. Sir, current is entering from this side, but I will try to do one thing. I will try to find out from this side. Arey, why you want? You want to fetch marks? No. Fetch marks and comes. Over. Exam over, tata, bye bye, game over. After that, why do you want to care about it? Right? So here in this case, current is entering from A and moving out from B. Here also A and B. So I will be interested in finding out the polarity at point A in both the cases. Okay? In both the cases. So now, what will you do? You will use the jugaad once again by the help of your index finger. So if this is your solenoid, the wire in the first case is going underneath because I don't see a line. I don't see any solid lines. So when I try to keep it underneath, and remember always in the forefinger the current is always moving upwards for you. That's why I tell look at the entry end of the current. So if the current is entering from this side, let's say this is the wire, it's going underneath, I hold it and turn and see to that this end is turning towards you. Please see to that this end is turning towards you and then find out the direction in which direction it is. Okay? So this is south polarity because clock and this is north polarity because opposite polarities. Whole code is same. Now the same thing. Let's try to complicate the questions a little bit. Okay. Again a solenoid. Let's change the entry point. this case now, the current is moving in this direction, so I'll find the polarity at this particular end. So it is going from the top. So again, this particular end, the wire is at the top, yeah, and I'll try to curl it, and I'll see to that this end is facing towards me, but it's difficult, so I'll try to use this hand. So now the wire is going at the top, turn it towards yourself, it is clockwise, which is south, and this is north. Similarly over here, it is going underneath, so I'll use the other hand and face it towards yourself. This becomes north and this becomes south. Okay. Now, suppose this was the question. Both the solenoids are there. So at point K, what is the, if I place a compass, will it show any deflection? No. Why? Neutral point. Now will this point K be closer to this solenoid or this solenoid? Which solenoid? Solenoid 1 or solenoid 2? Why?
Number of coils.
Solenoid 1 has lesser number of wires, lesser number of turns. 3 turns, 4 turns. So please be careful on that also. More the number of turns, more is the magnetic field also. So K will be more closer to solenoid 1. Yeah, and K is where your net magnetic field is 0. B net is equal to 0. And it will be more closer to solenoid 1. Okay? Peace? Understood? This is where you have the solenoid related questions. Apart from that, nothing else will be there. So, chill. But solenoid question, if it has to come, okay, they can give you questions like this also. Deflection is given, but you need to find it out. You need to find out the solenoid. The terminals of A and B. So suppose here it is given as south polarity, here it is north. Okay. Now this is nothing but the current. Let's say we'll have to assume over here. Back to Faraday's. People who ever remember vaguely. Faraday's and lenses, what we tried to do, we always found out the polarity first. Correct? Based on the polarity, I found out the direction of current. And then I show the deflection in the galvanometer. Correct? Same thing over here. Here polarity is given to you. I need to see to that. I find the terminals of A and B. Sir, won't this be galvanometer? They are telling you to find out the terminals. That means there is a battery. AB is a battery. They are not telling it is galvanometer. Correct? So here, let's assume that the direction is going up. So when it is going up, again the same scenario. So this is how you see to that the wire is being held around the solenoid. Turn this towards yourself. Clockwise. Clockwise means south polarity. So is this south polarity? Yes. Sir, by chance, let's say whatever we assume is wrong. That means current direction will be opposite. That's all. Okay. So suppose this will be positive, this will be negative. In case, let's say, I take the scenario where let's say this is south polarity, this is north polarity. I need to find the terminals of A and B. What did I tell? Irrespective, I will see to that the current is moving in this direction. Okay. Let's say this is my assumption. Is this right? I don't know. I need to figure it out. How is the wire being wound around? It is on the top. So on the top, I'll try to hold it and turn this towards yourself. It is anti-clockwise. Anti-clockwise means not polarity. But polarity I cannot change. Correct? No? So, but given to you is south. That means my assumption is wrong. So when my assumption is wrong, what do? Just change the direction of current. So when you change the direction of current, it is understood that B is positive, A is negative. So this is where solenoid questions can come across. Another thing is, same scenario, let's take this into consideration. Suppose there was a compass now. Suppose there was a compass. It is held like this. If there was a compass which was placed in this way. Okay. So will this, so that means it is resting in north-south direction. Correct? So you know which is north, which is south, this is north, this is south, this is east, this is west. Suppose this is where you have your solenoid polarities. So this compass will show deflection towards the east or west? East. It will bend like this. Okay. Because it will try to get attracted towards the opposite, not this way. Okay. It will try to get attracted. This is also there in your textbook of page number. Page 255, right hand side column, fifth one. Right hand side column, fifth one at the bottom. DC motor. Okay. DC motor. तू आके पूछेगा ना डाउट, माँ कसम तेरे को लात मार के बाहर निकालूंगा आज. You come, don't come, that's the secondary thing. But please, you will have to respect the timings of every individual. Yeah. So DC motor. DC motors. Class was at 10:30. You are coming at 11:50. Literally 1.5 hours. Okay. Anyways, never mind. So DC motor, when I have a magnet, basically a conductor is being placed in between a magnet. And what type of magnet is this? Horseshoe magnet. You shape mere horseshoe magnet it is. Horseshoe magnet. Okay. In a DC motor, what do we connect? What type of rings do we connect? Split rings. Split rings or split ring commutator. Okay. We also have your carbon brushes. Why carbon brushes? So that there is less amount of friction and there is smooth connectivity with the battery, so that the current is easily flowing. If given a chance or if given a question, instead of carbon brushes, I will use plastic brushes. Or the girls, what they use, makeup brush, whatever it is called. Correct? No? You can't. Why? Because they're insulators, not non-conductors. Like carbon, copper, they are conductors basically, that's why. Now suppose I have A, B, C, D as my armature coil. When the key is connected, current is flowing in this direction. Now this is important, guys.
A, B, C, D.
Okay. Physics is important, don't focus on alphabets. Okay. So when the coil is, now here what happens is, there will be deflection taking place. Why does deflection take place? For that you need to know a little bit about Lorentz force. Lorentz force. So this bugger, what he told is, scientist, so he told that whenever there is a charged particle moving in a magnetic field, important is this statement, this part of the statement, other than the direction of the magnetic field. any charged particle moving in a magnetic field other than the direction of the magnetic field, keep this in mind, other than the direction of the magnetic field, will always undergo certain deflection or will be under the influence of some force. What did he state? Charged particle, this is important terms. Charged particle, it has to be, okay? It has to be in motion other than the direction of magnetic field. Then this will be under the influence of force, and this force is directly proportional to the current, directly proportional to the strength of the magnetic field, and directly proportional to the length of the conductor under the influence of magnetic field. If I state, they can frame good questions based on this factor. Suppose there is a magnet, and let's say this is the length of the wire, but only this part is under the influence of the magnetic field, correct? Which is, let's say, 5 centimeter. Another one I have which is under the influence of the magnetic field, which is, let's say, 3 centimeter. Now where will the force be more? Where will the magnetic force be more? The 5 one. Okay. But suppose, let's say, I say this length of the wire is 10 meter or 10 centimeter. But whereas in this is 12 centimeter. Now, okay, Gocho, it is still same, no, it is 5. How will this matter? This should not matter to you. This should matter. Length of the conductor under the influence of the magnetic field. Okay? It should always be length of the wire under the influence of magnetic field. Length of the conductor under the influence of magnetic field. Under the influence of magnetic field. Okay? Clear? Understood? So that is nothing but F is equal to IBL. Not IPL, IBL. Okay? Now, because of this Lorentz force, here as well, the current is flowing through. So when current is flowing through, which charge is moving? Electrons are moving in the opposite direction of the current. Result of which, what will happen? It will undergo a deflection. But the part of the coil which is nothing but BC and AD, they will not be under the influence of any force. And why is that? Because they are parallel to the magnetic field. They are moving along the direction, or anti-parallel, parallel or anti-parallel. But whereas in case of AB and CD, they will be under the influence of magnetic field and under the influence of a force, and that force, direction of force is given by F is there. So Fleming's left hand rule. Okay. Fleming's left hand rule. So where you see to that, you stretch the 3 fingers mutually perpendicular to each other. This has to be like this only. You cannot do this. Okay? It has to be like this. Where the thumb, it is father, mother, child. Father is force, mother is magnetic field, central finger is a child. So, this is the direction of the magnetic field, magnetic field north to south always. Yeah. Direction of current is nothing but moving up. Yeah. Place it like this. Peace. Central finger is up. Magnetic field is this side. So when I stretch my thumb, it is going into the plane. It is going into the plane. So CD will, what will happen to CD? It will be outside the plane. And remember, both the forces on the two parts of the coil, that is AB and CD, has to be equal. So two equal forces, equal and opposite forces not acting along the same line is couple. So this couple is responsible for producing a rotatory motion, result of which this armature will undergo a rotatory motion where this will come out and this will go in, so it will be in this direction, anti-clockwise. Okay, so here it will be anti-clockwise. Anti-clockwise. Left hand thumb rule. What else do you have to remember? It is nothing but coupled forces. Okay, coupled, because of which there is rotatory motion. Okay, but after every 90 degree of the rotation, what happens? No force is induced. Why? Circuit is open. Circuit is open after every 90 degree. Circuit is open. So then, sir, how will it complete its motion? Motion takes place due to inertia. Okay, right, completely inertia of motion. Okay. Will the direction of couple change? No. Why? Why? Because of your split rings. Because of your split rings, it does not allow the wire to get tangled. Split ring commutator function. It helps in reversing the direction of current after every 180 degree. After every 180 degree, current in the coil gets reversed. Okay, so that the deflecting couple does not change its direction and the armature is still rotating in the same direction. Okay, by deflecting couple is not changing, couple is taking place over here. Equal and opposite forces not acting along the same line is couple, result of which there is rotatory motion. In this case it is anti-clockwise direction, but after every 90 degree what will happen? The coil will lose its connection with the battery. Circuit is open, but due to inertia of motion the coil will complete its rotation, and that is nothing but it takes place another 90 degree rotation. Now when it is 180 degree rotation is completed, the current in the coil gets reversed because the armature becomes now BCBA. So reverse in the direction of the current. But is the deflecting couple changing its direction? No. So will the rotation be changed? No. Okay? Understood? So which rule will I use? Fleming's left hand rule to find out the necessary thing. Okay? Fine. The function of split rings. Function. Remember this fellow's function. Okay? What does it help you to do? It reverses the direction of current without reversing the direction of the magnetic field. Peace. What type of energy is change is taking place here? Electrical energy is changing to mechanical. Example, real life example, DC motor, sugar cane juice follow, fan, okay, machine bro, machine. Oh, by the way, when is this force maximum? When it is perpendicular to the direction of the magnetic field. But if it is acting at any other angle, will deflection take place? Answer is yes. Only it should not be parallel and anti-parallel, that's all. But any other direction, let's say if this is a magnetic field, okay? This is the direction of the magnetic field, okay? And if the force is acting like, or let's say current is acting in this direction at an angle theta, will deflection take place? Answer is yes. Answer is yes. But if it is parallel or anti-parallel, it will not. But let's say this is the direction of your magnetic field and this is the direction of your electrons. Now, where will the force be? So immediately what you need to do is, please do the new diagram. Magnetic field, current is this. So this is magnetic field, this is current. So it is going into the plane. Force is going into the plane. Clear? Please see to the opposite direction. Current and electrons always flow opposite to each other. Please remember the principle. What does the principle state? Principle of DC motor. I am asking the principle, he is telling me the rule. Force experienced by current can So whenever there is a current carrying coil, okay, the conductor will experience a force. Okay, this is the principle on which it works. Now, the coil when it is at 0 degree and 180 degree, will BC and AD will be under any influence of force? Answer is no. Correct? Now when it is perpendicular, will BC and AD be under the influence of any force? There is no force. Why? No force is any part of the coil because there is no current flowing through. There is no current flowing through. Okay? ये तो गलत जवाब मत दे रही। कल भी गलत जवाब दिया ना तू। When I saw the CFQ answer, it is given false. You are telling no, it was true. For that statement where I versus R, it is false. I asked you what is the CFQ answer. You are telling both are true. It is false. तो बोलना चाहिए नहीं कहता। No, when I said it, 30 बच्चे उधर ही थे. So all the 30 people literally will go wrong now if in case this question comes. Correct? No. You should get marks, but also be truthful to yourself. I asked you, did you see the answer? What is the answer given? You just stated.
The options, see, the back, but then the options are mixed in this.
Okay. My bad. I'm sorry. My bad.
No, my bad.
I told no. Just a matter of today. After that, घंटा मेरे को फर्क पड़ता है. एक दिन, I just prayed God and came. Just only one thing. Stay calm. Just stay calm. कोई कुछ भी पूछे वैसे यहाँ. Just give a smile. Tomorrow is impossible that I'll be there at the institute.
You told you go to Thailand for spa. Yeah.
That is when you people write the exam. Monday I'll go because tomorrow 12th will catch hold of me. Math no there. They'll be like, sir, we need you. So that's why. Ah, break. Okay, fine.
Pause.
Here's the second part of the chapter, which is nothing but from a magnetic field. We are trying to generate electric field. It's all based on rate of change of magnetic flux. The entire part of this is just based on only one thing, which is nothing but phi. What is phi or delta phi? Change in magnetic flux. So what is change in magnetic flux? The magnetic field lines that is entering the conductor of the coil. Okay. So the very first experiment again over here, whenever there is no electric field but magnet is being moved around or something is there related to it, remember always you should think about Faraday's experiment. Faraday's experiment. The AC generator and transformer only. Basically, under Faraday's experiment, you have your Lenz's law and Fleming's right-hand rule. Okay. Electromagnetic induction is the principle. Electromagnetic induction is basically nothing but the principle for all. You have AC generator and last but not the least is your transformers. Okay, last but not the least is your transformers. So under Faraday's is where you have your Lenz's law, and the direction is given by Lenz's law and Fleming's right-hand rule. Fleming's right-hand rule. Correct? This is the entire part of it. Especially in this part, please focus on transformers more. And Faraday's experiment. Enough. Sir, AC generator, relax, calm down, nothing will happen. Okay? They will not try to mess around with it. Yeah. So Faraday's experiment says that. Anyone with a conclusion? Anyone? I don't need exact statement.
Whenever there's change in magnetic flux, the coil does EMF.
So, what happens over here is the rate of change of magnetic flux linked with the coil always produces a current or always induces a current around the conductor. So what I said, rate of change of magnetic flux. Now how will there be a rate of change of magnetic flux? This rate of change of magnetic flux or change in magnetic flux is always due to relative motion. Relative motion. Always due to relative motion between whom? The conductor and the magnet. Between the conductor and coil. Conductor and magnet. Sorry, coil is this one, conductor and magnet. So whenever there is relative motion between the two, there will be change in magnetic flux. The result of which, what will happen? There will be current induced. Okay. So here we have things related to solenoid. Yeah. There is a galvanometer which has been put across. Yeah. And there is a magnet. Bar magnet, north south. Suppose now there is some magnetic field. Yeah. So when the magnetic field is there and there is no change in magnetic field lines, what will happen to this galvanometer? This will stay at rest. It will not show any deflection. But let's say there is the distance between the magnet and the coil is either increasing or decreasing. Okay? Either it is increasing or decreasing. Whenever it is increasing or decreasing, we say that there is relative motion. There is relative motion between the two. Sir, what is right now? Don't think about that. Just think about only one simple thing. Sir, if the distance between them it is increasing or decreasing, there is relative motion. If there is relative motion, there is change in magnetic flux. Now, if there is change in magnetic flux, current is induced or EMF is induced. Okay, current is induced. This should be the flow. Can I have high flow? Sir, if the distance between them it is increasing or decreasing, that means there is relative motion. If there is relative motion, there is change in magnetic flux. And if there is change in magnetic flux, EMF is induced, which is basically nothing but called as electromagnetic induction. Current is induced. Okay? Clear? Understood? You understood the flow chart? This is what happens. So let's say now the magnet is brought closer. So when the magnet is brought closer, what will the conductor try to do? The conductor will try to oppose the change. Correct? Right now it is in equilibrium, boss. If it is in equilibrium, why will it change? So now when it is in equilibrium, okay, and I am trying to change this or I'm just trying to see to that the equilibrium is being disturbed. So what did Lenz say? Lenz's law states that it will oppose that motion. So if I have to oppose the motion, then I have to have same polarity. I have to have same polarity. So this is north and this will become south. Correct? First scenario, how do you solve the question? First is find the polarities. Find the polarities. Okay, by Lenz's law. Now when I find out the polarity by the Lenz's law, okay, second thing is my assumption of direction of current. And then use clock rule. Then use clock rule to check. Okay, which is nothing but if it is clockwise, it is south polarity, and if it is anti-clockwise, it is north polarity. Again, what will I try to do? Here this magnet is being brought closer. So north polarity is being present, like induced over here, and this is south polarity because there is change in magnetic flux. Now I will assume that the direction is going upwards. Current. So how do you know it is up? I am assuming. Then after that with clock rule I will check. So clock rule says that suppose the current is now here underneath. The wire is underneath at this. Correct? I told you always for a solenoid what will I do? I will always try to find out the direction where the current is entering from. Okay? So here underneath it is moving. The wire is underneath. I will try to hold the solenoid. Turn this particular end towards yourself. It is clockwise. So if it is clockwise, which polarity? So that means it is south polarity. Yes, that means my assumption is correct. So current is flowing in this direction and the galvanometer will deflect towards this. Arrow will always move towards the direction of the current. Okay? Arrow will always. Gina, someone's asking for you. Your dad probably. Okay, never mind. Let's go ahead. Alright. Understood with this? Clear? All peace? The question can also be reversed. What is the reverse process? Sir, they will show you the deflection. Then I have to decide whether the magnet is brought closer or moved away. Sir, example. So let's say same question, guys. Or do you want to do different? Okay, different. Okay. This is the deflection of the galvanometer. Okay? And this is a magnet with north south or south north? So south north. It will be same question then. I'm changing two things. It will be same thing. So now, if the galvanometer is showing this deflection, indicates that current is flowing Okay, current is getting induced. Chalo bhaiya, we are done. Now when the current is moving in this direction, I can find out the polarity. Just like your solenoid part. So the wire is going from the top. Correct? When it is going from the top, yeah, I hold it and see to that I turn this particular end towards myself. It is clockwise. So if it is clockwise, it is south polarity here and it is north polarity here. Correct? Now if polarity is being induced, polarity is present and current is being induced, that means definitely either the magnet or the conductor is moving, or both can also move. Both can also move. Condition क्या है भाई? Either the magnet or the coil is in motion, or both are in motion. So basically when I state that both are in motion or either one is in motion, it is basically nothing but relative motion. Understood why we use the word relative? Yeah? So that means the distance between them right now, what I can state is that there are multiple cases that can be formed over here. There can be multiple cases that can be formed over here. And in one, I will try to explain each and every part of it. First condition, sir, only magnet, give the answer only with respect to magnet. Is the magnet brought closer to the coil or moved away from the coil? Closer. First condition, done. Second condition, give the answer with respect to the conductor. Closer. Okay. Third scenario, both are in motion. Both can, the condition is that both will move closer to each other. Another condition. Anyone with another condition? Another two conditions. Let's say here this is moving with 10 meter per second. Then this fellow can move with 20 or 15 meter per second. What did I tell? Whenever it is with different speed, cancel out the one that is moving with a lesser speed and consider the one that is moving with a greater speed. I can also state this as 2V and this as V. Okay? Any other possibilities? Yeah, the other one is whether it is, now let's say this is 10 meter per second and this is 15 meter per second. So there are multiple possibilities. Ultimately what you should remember, you just focus on this. You just focus on this. It will be easier for you. Okay? And based on your option you can choose one. So that means if the distance is decreasing, it is same polarities between the magnet and the conductor, same side, which are faced at each other, which are facing each other. They will have same polarities if the distance is decreasing. If distance is increasing, it is opposite polarities. This is important, guys. One is this, another one is this. Based on which there is relative motion I can conclude, change in magnetic flux I can conclude, current is being induced. So multiple questions can be framed. Yes, now you can go ahead.
So if both the coil and the magnet were to go at the same speed in the same direction, by the same distance, there is
No,
change.
no change. Clear? Understood? This is something which is very important, guys. So Faraday's experiment so just important. Okay? This chunk is the most important chunk. Okay? Suppose, guys, another thing. Suppose this magnet is moved to and fro. What will happen to this fellow? It will keep on deflecting. It will keep on deflecting. Okay? In case, if I take the magnet, move it closer, galvanometer will show deflection and I stop. Now what will happen is, it will come back to rest. Now there will be no EMF induced. The moment I stop, After a while, instant amount of time, it will stop. Clear? As long as there is motion, there will be EMF induced. Relative motion, Faraday's experiment. AC generator. So AC generator, again we use a horseshoe magnet. We use slip rings. Now slip, not split. Slip rings. We use again carbon brushes. Armature and all those things. Yeah, necessary things. Okay. So there is an armature. This is the coil. Carbon brushes. And there you have your load. This is slip rings and these are carbon brushes, guys. Here it is complete slip rings. Why? So that the connectivity is not lost. Firstly, and continuous flow of current is there in your load. In between a horseshoe magnet. What are we trying to do with the axle? We are trying to rotate it continuously. Okay. So mechanical energy is being converted to electrical energy. So the principle on which it works is electromagnetic induction. A, B, C, D. Again same scenario, in whichever direction I am rotating. Okay? After every 180 degree, what is happening? There is a change in current, flow of current in the armature. Okay? And the current that is being induced or the current that is being produced is a alternating current. Alternating current. EMF, rotation theta. When it is 90 degree, it is maximum. Perpendicular time, it is maximum. Okay? This is an alternating current. But if I want an alternating current to become nothing but, let's say, DC. Alternating current in the form of a DC, let's say. How is a DC current? This is how a DC current is. If anybody is checking, so this is your EMF and this is with time. Okay? DC or magnet of current. We have a constant magnitude of current. This is DC. Okay, graph. They'll not ask you earlier, back then it was there. Now if I want this AC to get converted to where basically this part is not there. Okay, I don't want it to be like this. Basically nothing but everything should be in the form of positive. So this will go up, this will go up, this will go up, and result of which what will happen? A constant line you will get. So if I want the conversion of an AC to a DC, we use a rectifier. We use a rectifier. Rectifier is not there, but just putting it across in case. Okay. Here you don't require anything, people. Actually, there's nothing much in AC generator, so they will not ask you what. Okay. If they ask you, they'll ask you 1 mark and all. Like, what is the principle? What is the conversion of energy? All those things. Okay. Post that, you have transformers. You will wind it. So if I say the frequency of an alternating current is 50 Hertz, what do you mean by this? 50 positive, 50 negative, 100 times up down. Okay. And what is the voltage of live wire? 220 on in the house, Indian house. Okay. Earth wire, neutral wire, 0. So there is one question in the CFQ that I have put across in that last this thing. There is one question where they have given and they asked you which wire it is. They have given the difference between the potential. Check that out. It's a good question. Yeah, absolutely. So transformers. People, this will save you in your section B. This will save you in your section B. Please study this properly. Theory hai. Learn the diagram of step up and step down. Step up, step down. What does the step down do? Output voltage is lesser. Voltage output is lesser than voltage input. Here it is, voltage output is greater than voltage input. If voltage is greater, what about current?
Current will be
Current is lesser, output current is lesser than
input current.
input current. Number of turns. So secondary, output is always a secondary. Number of turns of secondary coil will be greater than number of turns of primary. In that case it is ulta. In that case it is dead ulta. Okay. And remember, turns ratio. Turns ratio is NS by NP, not NP by NS, which is greater than 1. NS by NP. So basically it is nothing but ES by EP is equal to IP by IS, which is equal to NS by NP, which is nothing but basically our turns ratio. Okay. If current is more, the wire is thicker or thinner? Thicker the wire, more is the current. Okay. Thicker the wire, more is the current. So diagram, just remember the schematic diagram for both of them. That's sufficient. And what type of voltage do we supply here? AC. We supply always AC voltage. Why AC voltage? There should be change in magnetic flux linked with whom? Secondary coil. Always focus from primary to secondary, no? So there should be change in magnetic flux linked from the primary to the secondary coil. Okay, that's why we always use a AC current, not a DC. Principle that it is based on is electromagnetic induction. Because of change in magnetic flux, there is EMF induced in which coil? Secondary coil. Okay. Apart from that, loss. Losses are AC current. Now, as the name suggests, the loss due to the current which is flowing through. Correct? How can we minimize this? How can we minimize? By laminating the core of the transformer. Copper loss and hysteresis. Okay. So copper loss is due to heat. So how can I reduce that? By having thicker wires of low resistance. Hysteresis is due to the magnetic flux. Okay, magnetic flux or field lines which are not completely linked with secondary. So how can I see to that? I need to place a soft iron core. I can reduce it. Okay. So these are the three types of losses. Please remember them properly. Apart from that, one more thing in transformer is that we always use the transformer in the shape U-shape. U-shaped wala or completely closed one. Okay, U-shaped or completely closed ones. Okay. Again, so that there's the efficiency increases and there is proper linkage of the magnetic field lines. That's it. Thank you guys.